So then when you move on from even just software, you start looking at some of the more modern things like cloud providers. A lot of organizations are putting a lot of trust in the security of cloud and assuming to a degree that everything that they're using is secure. However, when you have a look at some of the vulnerabilities that have come out, last year, Checkpoint actually discovered two major security flaws in Microsoft Azure. So this was basically where, so Azure let you have the Azure apps, which you can, fire up applications as a PaaS or a SaaS style environment. And you can just go and launch websites. You don't have to look after servers or anything like that, which means that anything underneath your website is controlled and managed by Microsoft or Azure. What Checkpoint found was that you could actually break through the sandbox that's hosting your app and actually break into the underlying Azure infrastructure and get access to the fundamental infrastructure that's running Azure, and therefore gain access to a large number of applications that are being hosted within Azure and be able to manipulate those and backdoor them and those sort of things. There's other interesting things that have come out with, and I find this specifically around some of the Azure services, is just does my head in around some of the design decisions that they make to actually get some of the features out. So up until recently, and I think this is still only in a preview mode, the current Azure Key Vault, is basically there to store secrets and store passwords and encryption keys and certificates and those sort of things. And when you look at it from face value, you say, all right, it's a key vault. It's been designed and implemented by Microsoft in Azure. It must be secure, right? However, when you actually look at the functionality of Key Vault, when you look at it from an organization perspective, you might have one solution one system that might be a database, and it would connect to Key Vault to pull down or connecting to a database, pull down the authentication to be able to connect to a particular database. Right? There might be a web server that needs to get its certificates, for example. So it would connect into Key Vault and get its certificates and set up things like encryption and those sort of things. There might be some encryption and decryption keys for data, maybe in a secure data warehouse or maybe in a bucket, those sort of things. The application connects to Key Vault, pulls that out, gets access to its decryption keys and things. When you look at those in an isolated way, that all seems okay. The problem is when you look at how Key Vault's actually implemented, if you have access to the Key Vault, you have access to everything in the Key Vault. So, that application that's connecting to a database, maybe it's a wiki site, for example, a recipe site or, something, not highly sensitive, and it gets access to its own database. It actually has access to everything in Key Vault. So it could download the decryption keys for data, it can download certificates, it can download clear text passwords out of it. So if that system gets breached, basically all of your authentication and sensitive data gets breached through Key Vault, and then it's basically trivial to then go and escalate your privileges throughout that Azure environment. So that's just another thing that you need to be aware of when you're looking at supply chain attacks, is not necessarily the company getting breached, but also just the implementation of some of the security controls. So thankfully, the preview mode of Key Vault, they've started implementing IAM policies so that you can start restricting what individual systems can actually access within Key Vault, which is great. And that's how it should have been implemented to start with, because a lot of companies we talk to don't actually realize that's how Key Vault works. and didn't realize that their whole environment was exposed if something got breached. Okay. One of the presentations we did, myself and one of my team, Paul Kalinin, we did a Black Hat presentation a few years back called the Active Directory Botnet. And this took advantage of where we basically turned your Active Directory or your domain controllers into a command and control point, and basically used an attack technique where we use, because everything can basically connect to Active Directory at any point, even in globally distributed environments, and the domain controllers are all synced, then a system on one network can actually send messages through your domain controller through the attributes. So it can write attributes and it can read other users' attributes. And that creates a two-way communication channel through your domain controllers. So what that does is ultimately turns your environment into a flat network by communicating through AD. But what actually, from a supply chain perspective, again, when you start introducing cloud and you start having syncing through to your Azure AD, for example, what a lot of people don't realize is that Microsoft exposed this thing called Graph API. And Graph API is an internet accessible API that any one of your users, doesn't have to be privileged, can authenticate to Graph API and start querying things within their permissions. So what we actually did was to be able to interact from the internet with compromised machines on the internal network through Active Directory. We could actually, from the internet, communicate through Graph API, authenticate with just a single user account, could be a standard user account, and actually then use Graph API to communicate to all of our bots on your internal network, and actually then gain shells through Graph API to the internal network to actually start launching attacks. So, it may seem nice and trivial to have things like, your cloud APIs accessible on the internet. You also have to realize that there's attack vectors that you can use to actually abuse those APIs. And there's probably a lot of functions there that you don't actually realize exist that are introducing risk to your business, like a standard user who's been able to authenticate to your Active Directory from the internet. So when you look at that from the perspective of how many leaked passwords, usernames and passwords that are going out every single week, I only need one of those credentials to work. I can then authenticate to your AD through Graph API. There's also things like, domain takeovers, and they can affect your organization. So obviously, your domain registrars and making sure that you're set up in there is secure, but also if those registrars get breached, that can have a major impact on your organization. That's happened numerous times over the years. I remember there were some Google domains that got hijacked as well, but there's also others which are not necessarily the registrar that gets breached, but when you start using places like AWS and Azure that have multi-tenanted SaaS or PaaS solutions, where you're interacting with, say, their CDN, for example, and everyone's domains are getting exposed through the same CDN. If you register a domain and it points to, say, the Azure CDN, and then and that gets set up, and then you remove that, you can actually hijack things like the applications in Azure. So one of our guys actually did some research on Azure, and Microsoft actually uses Azure apps for a bunch of their domains, and they then they point their DNS to it. So all of their different subdomains for their apps, they point those to Azure, and then they go, all right, we've actually finished with this app, and they delete it, right? So maybe it was marketing or something along those lines. And what that means is that the DNS is still pointing to Azure, but the actual app doesn't exist in Azure anymore. And anyone in Azure can then go and register that app. And one of our guys found that he could actually register, or he found that he could register hundreds of Microsoft domains or hijack hundreds of subdomains of Microsoft.com because he could just simply go into Azure and register those apps, which Microsoft already had the DNS entries pointing to. So there again, some of the other flaws that get introduced through these third-party cloud supply chain providers that you really need to be aware of. And he's been working with Microsoft for a long time now to try and get these closed out. But they just have so many and it's so dynamic that they actually still haven't closed out a lot of these domains. So it's not just a problem with Azure as well. That's a big problem with other providers, but it's fundamentally the company's problem who's deleting the apps and not deleting the DNS entries pointing to those. So that's how you can do those domain takeovers.